So all these alternate paths or alternate mechanisms have to be thought of, they are talking about. Right. Now, consider adding variations and exceptional events after a normal cause has been accounted. For example, in an ATM, if a cancellation request is issued just immediately after submitting it, or the other user might not respond to the instructions on the machine. Right. So a good designer, after completing these steps, will validate the diagram, examining whether all events and scenarios have been covered. This can further lead the designer to suggest some events that have been handled and can impact the state. Consider the state chart diagram building for placing the order on the website. Right. The activity diagram in figure 10.4 shows the steps for placing an order on the website. It is clear from the diagram that the order class is having different states while the order is being processed. So here they are showing you consume the consumer is there, system is there. So a sequence kind of a thing, or a activity diagram kind of a thing they have there. So initial state is there, then connect to the order page. It goes to display the order page on the system. Then connect as a guest or registered user. It goes to or create order placement package. Then search in catalog on or view items. Then it goes to display the search goods, and then add goods to the shopping cart. Then add good to order. Then there is a end for each end of order, right? Display summary and order totals. Then make modifications, update the order, enter payment details, display payment option, and finalize order, and end of the activity, right? So the object transition takes place from one state to another as messages are passed to different states. So you have states like open and add items, right? You have to open a page or open a placement page or whatever. Open and add items ready to be shipped, item being shipped, waiting for back orders, shipped and closed. So I open and add item is order complete, item ready to be shipped, start shipping, being shipped, current shipping, waiting for back orders is arrival back orders, shipped, payment clearance, closed, no exit transition required. So this kind of a thing. Now first cut state transition graph for order class. So here again initial state is there, then order created. So open and add items. So item is added to this class only. Then order complete, then it goes to item ready to be shipped. Then shipping is started, it goes to the shipping module. Then shipping being again a sub activity is going on, that being shipped is current shipping back orders, and waiting for back orders to be completed, then arrival of back orders, then being shipped goes to shipped, and then payment clearance is done and order is closed and saved, and end of the activity, right? Then this one is design state diagram for the order class. Now this state diagram is being designed. So here again initial state, order created or assigned default values, then item add or add a new item, detail displayed, open and add item. Then here it goes to item ready to be shipped, order complete, calculate tax, total update, status on page. Then payment by credit card. So a condition is there, payment by credit or payment uh, uh, payment is done by credit card. If payment is accepted, then it goes here start shipping. If payment is rejected, you go to the end state. If payment is accepted, you go to the shipping state, start shipping. So again another activity starts, being shipped. So it checks for the current shipping back orders, waiting for back orders. If it is inventory replenish, if it is okay, now being shipped is shipped, and then payment clearance, order close, and save and end. This is how they have shown state chart diagram finally. So examining against other state diagrams. So this is an example they have shown you. The state diagram for each class can now be examined for their consistency and completeness. Examine states for having both sender and receiver messages. Examine states for their predecessors and successors along with starting and ending points. Examine the input event sequence from object to object so that scenario they represent are validated. Then examining against class model, examining against sequence diagram, So state diagram need to comply with their domain and application class models. For example, it is possible that many ATMs can concurrently try to access an account, but it needs to be ensured that only one update is applied at a particular time. The consistency of the account has to be maintained. Then examining against sequence diagram, the compliance of the state model with scenarios of timing diagram has to be examined. Simulation of behavior must be performed with hands to verify the correctness. In case of an error, modification in the state diagram or scenario would help remove irregularities. These irregularities could be in both, either in the diagram or the scenario. Tracing out legitimate parts of the state model can bring into picture additional events which might or might not make sense, hence need to be examined closely. Now, another thing is adjustment of inheritance. It would be convenient to create inheritance hierarchies between classes as we proceed further with the design. The following steps guide understanding the adjustment of classes and operations. So, rearrangement of classes and operations to augment inheritance, abstractions of common behavior from a group of classes. So, you see what all classes have a similar kind of a behavior or that. So, you make a inheritance according to that. So rearranging classes and operations, when we examine classes during design, we find that several classes define the same operations. In such a case, creating an inheritance hierarchy using common ancestors in common practice. Though often these operations in different classes are not identical, hence to include them with a single inheritance, the definition of the operation must be adjusted as per need. So you have to see which classes have a similar kind of a behavior. So you have to group them or make a inheritance hierarchy according to that. So there are four different ways of adjusting the different types of operations to improve the chance of inheritance. Operation with optional argument, operations that are special cases, or generalization of names, irrelevant operations. So here, operations with optional arguments. Alignment of signature is possible through optional arguments. The optional arguments can be ignored where they are not used. For example, drawing operation on a black and white display screen can add a color parameter to it as a signature for creating the alignment, but the drawing operation can ignore or accept the parameter depending on the type of display. In the case of black and white displays, we can ignore the given color parameter or argument. Then operations that are special cases. Some operations that have a smaller number of arguments are normally special cases of general operations. So such operations can be adjusted by using appropriate values for parameters in the generic operations. For example, inserting an element in a list is a generic operation, and appending an element becomes a special case where the element is added at the end. Then generalization of names. Attributes having different names in different classes must be homogenized. These attributes which have been homogenized will have the same nomenclature. They can now be moved to parent classes. Operations that access these attributes will also match appropriately. Just as attribute names have been homogenized, even operation names need to be homogenized. Right. Irrelevant operations. Consider the classes in a group. Some of them might have a elaborate definition for operations, and other classes might not have any operations. Such operations can be moved to parent classes, and while declaring these operations, they can be specified as no op for those classes which do not use them. Right. So these kinds of things for inheritance you have to keep in mind when you are rearranging the classes according to inheritance. Then abstraction of common behavior. So while adding new classes and operations during design, the opportunity of adding inheritance hierarchy can also be explored. An inheritance hierarchy is easily recognizable amongst two classes with repetitive operations and attributes. They could possibly be specializations of the same thing, giving a higher level of abstraction. As in every inheritance relationship, a common superclass is created in which the common features are abstracted out and specialized features are defined within the subclasses. Hence, abstraction can be defined. However, it is good practice not to create direct instances of superclasses. The draw operation turns out to be a good example of this relationship, as the draw method could be used for rendering circles, squares, and yeah, sorry. The draw operation turns out to be a good example of the relationship, as the draw method could be used to rendering circles, squares, and lines in the specialized classes, but attributes like thickness, color of the figure, and type of line are elements of the abstract class shape. Right. So inheritance is a valuable proposition for project future projects. Even though looking at the current scenario, as we can see that multiple subclasses are not an immediate requirement. As in the current classes, there is no probability of sharing behavior. But while designing potentially reusable classes for future products should be considered. Inheritance promotes modularity as specific aspects are separated from general aspects in inheritance-based classes. The creation of abstract classes also allows the software to be extended in different frameworks. Imagine that you are developing a gas leakage sensing module for a large factory so that leakage can be detected quickly and there are no fatalities. So, for that purpose, the module designed for one factory requires the detection of methane or butane gas, which can be detected using a specific sensor, say MQ2. So the module for gas leakage detection could use a single class with one instance for each sensor used in the factory. However, if we keep in view the future scope of the project, it might be possible that there could be other factories looking for similar deployment. But this deployment would require other types of gases to be detected through different sensors. So to meet this requirement, it would be a good idea to create a superclass sensor node which contains the common behavior of sensors and subclass sensor MQ2, which provides reading and detection particular to sensor MQ2. So now the leakage detector system of a factory is deployed in another factory which requires natural gas LPG detection. We can simply create a new subclass sensor MQ5 and specialized behavior can be added to this class without any changes to the existing class. Right? That is what they have shown here. So you have created a abstract class or a superclass sensor node. So here name, category, threshold, value, sampling window are the attributes, and you have two subclasses: sensor MQ5, sensor MQ2. So sensor volt, sensor value, sensor MQ5 in gas in. So other different methods are there for this, and sensor MQ2 have sensor volt, sensor reading, and then other methods of its own. That is what they are talking about. Another aspect which improves with abstraction is the maintenance of software. Suppose this software is being distributed to many units of the same plants where the configuration is different for every unit. Imagine the kind of complexity that would have been introduced if a customized version has to be created for every different sensor. But this complexity could easily be handled if one software version contains a subclass for each model. After deployment, the software inspects the configuration file and creates instances of particular subclass for sensors available in the corresponding class. That is what they are talking about when we are talking about inheritance, right? So you can create inheritance classes if you have similar behavior and all that. Then design of associations. As it is known, the diagrammatic representation of classes in UML is differentiated from its instances using an underline below their name. While progressing towards design, there are three major issues related to association that must be determined, right? Identifying classes to be implemented, identifying types of attributes, mapping composition relationships. So decisions related to retaining classes identified during the analysis phase must be made along with adding any other supporting classes. So attributes of classes can be rendered as private fields or members of the class. In the case of an optional attribute, the only change that can occur at runtime, that is corresponding field, might take a null value. So here car type have car has car details. This is composition, right? Name, model number, price, and here you have size of engine, horsepower, catalog number, color. So this kind of a thing. This is analysis model and this is design model. So in this they have added the data type also, and size of the engine, horsepower, category, string, all these things have been added. So in the design phase, the composition relationship has to be reconsidered. When we analyze a problem having the composition relationship, composition means full dependency on the other. So we found that relationship direction allows searching either from one end or the direction is bidirectional. But with design, restriction starts to appear on fields allowing interaction in one direction only. For example, at runtime, the owning object can access the object at the other end, but not in the reverse direction. So a decision must be made whether the relationship can be extended at each end or not. So here we have also given a arrow directed here that car type the direction of details can be get like this only, access like this. So as shown in figure 10.8a, while building the analysis model, a composition primary relationship starts from the composer card type class to the compose card detail class. The owner card type class fetches the information from the object, composed object, but not the other way. However, it is possible that the design requires the field card details to be embedded in both the composer and composed objects. Then that is also permissible by doing design. The mapping is done in a design by adding an arrowhead in the class diagram along with the rule and visibility as shown in figure 10.8b. Right. So during execution time, the messages flow in the direction of the arrow. Now we are talking about analyzing association traverses. There are three different kinds of associations: association plane, aggregation stronger, and composition strongest. Object-oriented languages do not have provisions to make any distinction between aggregation and composition, and hence consider all of them to be associations. Most of the associations that have been identified in the analysis phase and also the new ones end up as fields in objects, but the fields in a class permit navigation in one direction. Hence, in the design phase, decisions related to navigation have to be made. These decisions can be dependent on the multiplicities, one to one to many, and many to many relationships. So here, one way association is user logs into ACE portal login, right? If we look at the fragment of the analysis domain model diagram in figure this, there is one-to-one association. This association can be implemented in the programming language, three different possibilities, right? First alternative, one-to-one association representation in a design class diagram. This is one-to-one relationship. First way to implement the one-to-one association is to take the login association and add it to the field in user pointing to ACE portal login as in figure this, like this. The second way to it could be implementing login as a field in the ACE portal pointing to the user like this. This is pointing to the ACE portal login, and this is pointing to the user. Second alternative. The third alternative could be combining the two ways as shown in figure 10.5 and 10.6. 10.5 above, okay. To implement the two-way association. This is both classes are going to use a pointer field to point to other class. This could require a lot of synchronization, which is awkward to implement but possible. For example, the user class could contain a ACE portal field pointing to the ACE portal login class. Similarly, the ACE portal login would contain a user field pointing to the user class. Any changes in the field would also require updation in the original class. It is always a natural option to choose one-way alternative rather than linking the fields in both classes. An optional association with the multiplicity 0 to 1, similar to 1 to 1 case, accepting the field can be assigned null values, meaning no object at the far end. Right. So one or many and one. So one to many, you can say one to many association in a design class. Mapping a one to many association to classes also uses the same argument as for one to one class cases. The difference is that if a field in the multiplicity at the one end is added to the other class, it must store multiple objects. So for example, if a customer field is added to ATM card, there could be multiple customer objects. Hence, the ATM card requires a collection class to hold the customer objects. A list or array could be used depending on the availability of the construct in the language. Set bag could also be used, right? So this kind of a thing, a customer list, one to many association, right? Many ATM cards will be there with the customer. That's why. So that is what they have shown you in the advanced object design. In the object design, so choosing an algorithm, design optimization, implementation control, and adjustment of inheritance and design association. These are the things which they have shown here. On these also questions can be asked. What is design optimization? How do you do implementation of control? What is adjustment of inheritance? What is design of association? Something like that. These also can be asked in your theory examination. Then you have advanced object design, in which they are talking about, again here, An object, first they are defining an object. So an object is an important element of object oriented technique, and it can be represented as a physical entity such as car, truck, etc. Conceptual entity like any chemical reaction or process, or the software entity, for example linked list, stacks, etc. Object can also be defined as an instance of a class which is identifiable thing and linked with classes that are part of any application. Every object contains associated data, attribute, and has some features implemented in the form of functions. By using the concept of object orientation, and implementation of program can be decomposed into a number of objects. So here they are talking about object A has data and functions, object B also has data and function, object C also has data and functions, and how they are accessing the functions of each other. Right. So control and implementation. So to manage the activities of any system, many controls are used. Control means how the program change state from one another after giving the input. In this section, we'll discuss object states and representation of their behavior, like a state machine, chart diagram. So state machine object behavior can be modeled by using state machine modeling. Any event that affects the object state causing some occurrence of action, state transition is used to represent it graphically. So they are talking about state chart diagram, which we have already shown. A state is a curved edge rectangle is used to represent a state. So if and transition, the transition from one state to another is shown by an arrow from one state to another like this. So this is your state, and this arrow is your transition. So like here, for example, order management system, it starts from idle state and reaches to dispatch order state, takes taken in its initial and final state. So the you have this initial state, the darkened circle. So you are first at the initial state, that is idle, and then you go to the requesting order state, and then intermediate state. If not available, order requesting is not available, you go to the end state. This is end of the state. And if request or after request order, if it is okay, then choose type of order, right? And after type of order, you go to confirm order and to dispatch order and to the final order, like this, right? So the various parts of transition are source state. So this is your source state, right? Then events, whatever events are happening in between, right? Those are events. So it changes the state of an object from the source to the intermediate state after it satisfies certain conditions. Example include mouse click, entering a key, a software or hardware interrupt, right? Then a condition, if the required condition is satisfied, then it returns true, otherwise false, and no state change in state. And action, it is an outcome because of transition. A series of actions represent a scenario. For example, in an ATM machine, an error message action may come because of the wrong entry, or cash withdrawal action occur. If the condition is satisfied, it may execute while entering a state or exiting from a state. And final state, it occurs as a result of the last transition and action, right? So control as a state within program. The control means how the program changes state from one to another after giving the input. As we know, there are many ways to show control in a program. Control can be represented on an iterative approach using a loop or a conditional branch statement in the program, depending on the input trade. If there are many nested loop in a code, then input is transferred from low to high level until some procedure can handle it. Various steps involved in changing the transition diagram to code are mentioned. So how do you change the transition diagram, state transition diagram to code? First, detect the main and essential path. Generally, the flow of a program is sequential. So identify the states which are intermediate from the initial state, and this provides a path for the sequential events in a program, which are then converted into programming statement of a program. Check alternative routes from the main path that originates after satisfying some condition. These are written as a conditional statement later in the code. Identify the loop or iteration code in a program. Read the state transition diagram for all the circle coming back to the main branch. If these are several in each number and not crossing each other, nested loops can be generated within these backward jump path. Some backward paths will be implemented by means of go-to statement in a program. Unchecked can be a case of exception handling, And depending on the language used, it will get implemented by the usual status flag or error routes or exception handling statements or functions. Then control as a state machine engine. A state machine is a behavioral model. It consists of finite number of states. It needs an external event that will cause branching to the next activity. In other words, a state machine is event driven. One way of implementing control is to represent and execute the state machine engine. With this technique of defining classes and routines or stub, it is easy to do advancement from analysis model to prototype building. For example, if a transition and action table is provided, then it's easy to form a class named state machine. Each object instance contains state variables and can call a state machine engine to determine the state and the state required action. Each object instance would contain its independent state variables but call on the state engine to determine the next state and action. Then control as a concurrent task. Concurrency is identified and represented in the dynamic model. Concurrency allows more than one object to receive events simultaneously and more than one activity to be executed simultaneously. Generally, conventionally, concurrency needs to be avoided in programming and the sequential program approach is to be followed. However, parallelism has several advantages. The foremost reason to implement concurrency is that some tasks are inherently concurrent. Another reason might be the economical use of resources among concurrent tasks. The construct used to express concurrency are specified below. For implementing interleave concurrency, coroutine strategies may be used. Coroutines are organized at the same level. Another construct in the fork and join instruction with fork, simultaneous execution of two concurrent programs of the same code B is invoked. The sequential program may execute parallelly and interact just by passing messages or through variable sharing. Activities can be synchronized with the use of semaphores, but they are very unstructured and may be replaced by monitor construct. Executing entity thread with its associated data and other resources may be used to handle concurrency. Thread shares the same namespace and each thread has its own resources and data which allow concurrency within the process. Process is known as project active object and has a thread of control. So concurrency in objects are considered in various ways. Intra-object concurrency occurs when several threads of the same process execute concurrently, and inter-object concurrency allows independent objects to execute simultaneously. So if many objects receive events concurrently causing simultaneous execution activities, but these objects are not interacting, then allow only one object per thread in a state transition diagram and a separate thread for other objects. So that what they are talking about in concurrency for handling multiple things. Then they are talking about inheritance adjustment. Sorry, inheritance is the way to create new classes from the existing ones. The new classes for class formed is called child or derived or subclass, and the already existing class is known as base, parent, or superclass. So inheritance types include single, multiple, hybrid, multi-level, and hierarchical, and there are different types of inheritance. So with the progress of object design, one of the issues that arose that was adjustment of inheritance. We have to adjust the inheritance. The definition of various classes and operations can be adjusted for the adjustment of inheritance. To increase inheritance, the following steps should be performed: rearrangement of classes and its operations, abstract common behavior out of group of clusters. If more than one class shares a common operation and attribute, then make use of abstraction and form a superclass which contains shared properties or features and leaves only specialized features in subclasses. Apply delegation to share implementation following readjustment causes an increase in adjustment. So you have to apply delegation also so that you share the implementation following readjustment causes in. So that is there. So first parameter which should be followed is rearrangement of classes and operations. So inheritance can be increased by making the various adjustment as mentioned below. Some operations may have optional arguments. Operations contain fewer arguments and are special cases of general arguments. Attributes with likeness and difficult names in various operations can be transferred to a parent class so that all operations can access them. Inconsistent naming strategy for operations can be avoided. Some common operations can be included in the parent class and may be relevant for some base classes and irrelevant operations for others. Hence, it is declared as no operation in them. Right. Then abstract the common behavior in classes. So abstraction results in modularity. So if two or more classes have common behavior, a new superclass will be fabricated containing the common features of all subclasses and the base classes only containing the specialized features. Such abstracted superclasses can be identified and a library of these reusable classes will be created and will be used in future projects. So abstract classes also improve extensibility, right? Like string shape is an abstract class which is having color as a attribute and get area and toString as the uh, um, methods, and get area is an abstract method, that means it doesn't have a body. And there are two types of shapes, rectangle and triangle. These are the two classes, subclasses, where rectangle has length and width as the parameter, and triangle has base and highlight. And there are method, get area method is here also, get area method is here also. So this is the actual implementation. Abstract method will not have any implementation in the shape. In the based in the derived class or the child class, it will have the actual implementation. So in here, get area will have length into width, and here get area will have 1/2 base into height, whatever will be the formula, right? So that is how they have done that. So use delegation to share behavior when inheritance is semantically invalid. So inheritance uses a uh, transitive property where each subclass inherits attribute association and operations from their superclass. Inheritance follows is a relationship. Is a relationship. Inheritance follows is a relationship. The subclass inherits a superclass completely if operations of derived class override the similar operation of base class. In that case, it is said to be correct that the subclasses are specialization of the superclass. For example, consider the implementation of stack class, derived class, and a linked list class is already available. So the linked list class is defined with 5 operations: insert, delete, beginning, end, and display, and stack class with 2 operations: push and pop, right? Like this. So linked list has a stack like that. So it has 2 operations, push and pop, and other linked lists have this. Right. So now if a stack class inherit linked list, then it will also inherit not needed operation of linked list class. So if you inherit this, so it will also inherit insert, delete, beginning, and display also, which is not required in stack. So another way to implement stack is to delegate some features of linked list class. For example, push can be implemented by delegation of insert and end operation, and pop by the delegation of delete and end operation from linked list class. This one, right? You are delegating this one, right? So other operations are hidden and not to be used, as only required operation should be delegated. So in some cases like this, discourage inheritance and use delegation. Delegation is used where has a relationship is required. So this is has a aggregation, right? So stack can be a linked list can be implemented through stack also, that kind of a thing, right? So that is there. So this is known as inheritance implement adjustment. How do you adjust inheritance? Then association design. Association is defined as a relationship that exists among objects of different classes. We have seen association. So a link is used to represent this is your association. Link works in, right? uh, uh, the plan for executing of the association has been formulated in object modeling. The strategy can be a global for all associations to be implemented, or different techniques for individual associations. Two objects can be linked if there exists an association among their related classes. The link represents the path or link between the instances of the classes. Association described as a structural relationship among objects. It is represented as a solid line, mainly directed, usually includes labels, and often specifies multiplicity and role names like this. Person works in organization. And roles are person is an employee, organization is employer. These are the role names, right? And you define the multiplicity, many persons work in one organization, something like that. Then association modeling steps to be followed are Data driven view, behavioral driven view, right, define multiplicity. So data driven view, it is used to navigate between the objects of the classes. It is needed to show the association between two classes. So we are showing association between two classes. Data driven. Behavioral driven view is this allows the interaction between the objects of different classes. So this is your interaction works in, right? And define multiplicity and role name in both cases. So you are defining the role name and the multiplicity, one to many, many to many, whatever, right? So as an example, in the information management system of a college, they have shown you the information management system. They have shown you that there is a college has a relationship with student, that college has students, college has many students, one to many you can say. Then student apply for course, right? And the department has courses, many courses. Then faculty are part of the department, right? They work in the department, so they are part of the department. And there will be a HOD also who will be heading the department from the faculty. There will be HOD also. So aggregation represents the special kind of relationship. This is aggregation. Faculty are part of the department, so this is aggregation, right? So aggregation special kind between the whole and part. So this is the whole, department is a whole, and this is part. Faculty are part of the department. So composite association, in case there is a strong dependency between class 1 and class 2. As a result, if class 1 is deleted, class 2 is deleted. So if you delete the department, it doesn't mean that a faculty will be deleted. No, this is not a complete dependency on the whole part. So where there is a complete dependency, then it will be composite association. The two types of association, aggregation and composite. Composite aggregate is hollow diamond. Composite is filled black diamond, black filled diamond. So various constraints of UML associations are implicit relationship between object is on a concept basis. Ordered objects can be arranged in some specific way. Ordered means objects can be arranged in specific way. Changeable means relationship between objects can be modified. Add only means new connection between objects can be added at any time. And frozen means frozen constraints are constraints not allowed for modification of already constructed link. So if you are asked question about difference between association, aggregation and composition, here it is given. Association is denoted by arrow, denoted by an empty arrowhead. Aggregation, arrowhead means a diamond, denoted by filled arrowhead, black diamond. Then can be classified on one to one, one to many, many to many basis. And aggregation is weak association, and composition is a strong type of association. Then association can be in between two or more objects. Link objects can remain in the scope of a system without each other, right? Objects can remain in the scope without each other. Objects cannot remain, that this is a strong relationship. If one object is dependent on the other, strong association is there. So if one object is deleted, the other will not remain, the dependent one. And in this, the link objects can remain in the scope. If one is deleted, that doesn't mean the other is also deleted. That is aggregation. Objects are linked in association. Objects are not dependent on other objects. Yeah, sorry. Then so objects are not dependent on each other in aggregation. Objects are strongly dependent on each other, right? Example is relationship between student and teacher objects. Example is vehicle requires wheel but not every time of the same type. Example of relationship between the file and folder. If folder deleted, all files in the folder also deleted automatically. This is what is there. Then analyzing association traversals. Associations are inherently inherently bidirectional, right? If the association used in any application is unidirectional, it helps in easy implementation. As the requirement may change with time, there may be a need for a new association that traverse in opposite directions. For the prototype to work, a new behavior can be added, or bidirectional association may be included, right? So, in the case of optimization work, optimize some of the associations. So, associations can be defined as a family of links. It can link multiple classes. It can be classified as unary, binary, or ternary relationship. Aggregation and reflexive connects the objects of the same class. Association can be categorized as a weak association when two classes are linked and if the method of class 1 is using the attribute of class 2 or the return object of class 2. In addition, each association is characterized by three types of cardinality: one to one, one to many to many. Association degree tells about the involvement of the number of classes in a link. If it is unary, connects same class objects, binary connects two class objects, and ternary connects objects of three or more classes. So one way association, if we are talking about an association which traverses in a single direction, will be implemented as a pointer attribute containing the reference to the object. In the case of many multiplicities, a set of pointer is required for implementation purposes. Use list rather than set if many end is ordered, right? A dictionary object can be used in the case of multiplicity association, where dictionary consists of many instances that map selector values into target values. Generally, qualified associations with multiplicity many are rare. It is implemented as a dictionary set of objects. Then unidirectional association is there. For implementing unidirectional association, care can should be taken so that unidirectional is maintained. The implementation for different multiplicity are as optional associations. In this type of association, the class may or may not be linked to each other. It may be possible that customer have a current account or may not be. Consider the case of a customer association with current account like this. They may have or may not have a current account. One to one association. In one to one association, one class instance is connected to just only one instance of the other class. Consider a situation where manager is related to its department. One to one manager, one department, right? One to many association. In this association, single occurrence of a class is linked to many occurrences of other class. In the example below, one department has many employees associated with it. One department and many employees, right? It is not dependent, it is department, right? And the 0 to asterisk should be towards the employee. Then bidirectional association, it is used to relate associations that communicate in both directions regularly or on constantly, or it is also defined as an association that relates two objects in both directions. So a bidirectional relationship provides navigational access in both directions. There are many implementing ways for these types of association. In the first method, a single side association is implemented and a searching procedure is required in case opposite side traversal is needed. This is a special case where there is a difference in traversal frequency in both directions. This must be handled by minimizing both types of costs, storing and updating costs. Otherwise, the reverse traversal leads to an increase in the cost. In the second method, to implement binary association, the pointers may be used for traversal purposes. In this case, if the change occurs in any attribute of one class, then it must be updated by another class so as to maintain consistency. But to keep in mind that the number of updates does not cross the number of access. In the third method, the relationship between the class is represented by a new association class with the attributes. It is known as a qualified association. Two different objects are used for traversing in both directions. So note that the association class attribute may be part of either class in the case of one-to-one relationship, right? In the case of one-to-many relationship, attributes from many object class, and in many-to-many relationship, it is implemented as a separate class. So in case the association needs some attributes to be shown, then a separate class will be used. The below example shows many to many association between two classes, and a new class work on is added containing more details about their association. So here they have shown like this employee, and many employee work in many projects. So you have another class called works on. So this way you can show the bidirectional association. A third class, third association. This third method is used. This kind of a thing, right? For implementing bidirectional. That is what they are talking about. Then object representation. So object represent the state view of object-oriented system, and their behavior is defined only in class. Object should not be defined without the classes. Object representation means representing objects using an object model. So objects can be represented diagrammatically. Attributes of the objects can be presented in terms of basic data types, integer, float, string. In class, object designer task is to decide and identify how to combine and implement objects. So your object name is there, then attribute names are there. So rules for representing objects by using the diagram: analyze the system, identify all the objects. Important instances should be identified. It should be having some heading, shows some important association between objects, add comments or note wherever necessary. So here object diagram consists of objects and link to connect them with other objects. So object diagram of customer management system with objects like customer, order, priority order, normal order. So here you have customer, order 1, order 2, order 3, right? And this is priority order or normal order. What kind of order is another object they have added. So major elements of object model are abstraction, encapsulation, modularity, and hierarchy. Abstraction is defined as a system specification which focuses on some relevant properties for a user or viewer while hiding the details. Class encapsulate attributes and methods together which can be accessed by the objects. Modularity implies software or program is divided into various modules. Modules should be more cohesive, cohesive, and coupling between them should be less. Hierarchy in OOPS can be implemented by means of inheritance. There are various benefits of object modeling and representation. With the use of objects, all OOPS language features can be accessible. The reuse of design and software is possible by using object model. Application of object modeling includes problems related with various fields, with aviation, automation, robotics, banking, business, etc. Many complex problems can be easily implemented by using object representation. There are many ways for implementing or representing objects during designing phase, but utmost care should be taken by the designer so as to minimize cost, execution time, and memory space required. Consider an example of employee object where the identification number EIN is an attribute which is implemented as an attribute of the employee class or a new class formed for it. Right. In the first case, EIN, that is employee identification number, can be represented as an attribute of employee class. It can take any data type, either integer or string. In second case, employee identification number is implemented as an association to employee identification number object, which itself can either an integer or a string. This There is a trade-off between the two approaches, and it is the choice of the designer to opt for the best one. Right. So here in so this is a they are talking about you can have a new class also, a part of a class, a new class. Employee has employee EI number, which has EIN. So you can create a new class also apart from that. In the alternate method, the object designer may go for combining classes containing related objects. So in figure 11.10 shown below, there are two different implementation of a line class. One contains all the attributes of a class, and in the other representation, it is embedded as an attribute of the point class. So one is line is having A1, B1, A2, B2, all the parameters of the line class, right? All the attributes, and you can also have a line class, and you are having a point class which is part of the line. So point P1, you will have for P1 you will have A and B points, and for P2 also you will have A and B points, something like that. You can implement in separate classes also. So both of these representations will be used by object oriented designers depending on their choice. So what which one you want to use, that is your choice. That is what they are talking about. Then design optimization. It considers various design models constructed and trade-offs between time, space, cost, and other metrics, but does not leave behind the criteria or with case of maintaining implementation, extension, case of understand ease of understanding, reusability, and many more. A design model add detailing to support efficient information access. So the designer uses the analysis model as a framework for the implementation as it stores the logical information regarding the system. While designing a system, the correctness of the analysis model is required for efficient implementation and then optimizes. So your analysis model is most important, because if it is not correct, then your design will also not be correct. Some important points related to design optimization are, so you should know what are the important points for design optimization. Often a small part of the code is responsible for most of the time or space cost. So your small part of the code is responsible of the time and cost which you are taking. Optimizing critical areas is the best approach to work on all areas evenly. So you have to optimize the critical areas where the too much of time or cost space will be taken. So you have to optimize that. Optimize means you have to see how you will design that so that it will take less cost and time. Optimized system is more ambiguous and there is little possibility of its reusability, right? It is good to maintain the correct balance between efficiency and transparency. So these points you have to see when you are doing design optimization. Then tasks that need to be performed for design optimization: work on providing efficient access paths, reorder the computation of for greater efficiency, intermediate results should be saved to avoid recomputation. So they are saying while you are doing design optimization, these are the three things you should work. These are the tasks to be performed: work on providing efficient access paths, reorder the computations for greater efficiency, and intermediate results should be saved to avoid recomputation. So, adding redundant association for efficient access, as the redundant information is not of any use, so rearrangement of association must be realized to optimize critical aspects of the system. Let's take an example of an employee skills database. Operation, organization, identity, expertise returns all those persons in the specified organization a given skill set. Right. Consider an example where the organization has 1500 employees. Each one is expert in 5 tasks. Then the number of total entries becomes 7,500. To increase the hit ratio for any query, certain measures should be taken. If there is a need to improve the number of hits for any ask query, the classes or objects can be implemented by means of any technique like indexing or hashing, which increases the access to frequently retrieve objects. This may increase the cost, and there is a requirement for additional memory to handle indexes or hash table. So while system optimization, following points should be considered: examine each operation and see what association it must traverse to obtain its information. Identify all unidirectional and multidirectional associations. Next, for each operation, keep the following points in consideration: how frequently can it be accessed and what cost to perform it. Compute the fan out along the path through the network. The fan out of a class or method is the number of other classes used by that class or the number of other methods called by that method. Right? Keep the count of all associations that come across in the track and accordingly calculate the fan out for the complete path. Then nested loops can be avoided and frequent costly operations with a low hit ratio can be justified using indexes. Consider an example of withdrawal operation from bank ATM machine. All the transaction of cash greater than rupees 50,000 will take into account and will be informed to the government for further actions. The classes involved during this may include ATM to bank account to update account. All the updates of withdrawal operations are filtered against the checkpoint where cash greater than rupees 50,000 is withdrawal. This can be possible with the derived association from bank account to update account and would speed the operation. Then they are talking about algorithm optimization. In object-oriented design, it requires to work on data structures and algorithm both. The steps includes to perform are the computational order may be changed to increase the efficiency of the algorithm. Check if the order of executing the loop is correct. If not, then reorder it. Many paths in the code lead to dead paths. This need to be identified, modified, or removed from the algorithm. So this is how you will do algorithm optimization. Then saving derived values to avoid recomputation. So derived attribute values are based on the values of base class attributes. To avoid inconsistency in the update of derived attributes, three methods are used. Derived attributes are updated back to back as their base attributes are updated. In another method, as the base class attribute is updated many times and derived attributes are updated once all updation of the base class attribute is complete. Recompute derived attribute with the update of each base class attribute. This method is time consuming and should be avoided. So this is how you avoid recomputation. Then reification of behavior. Behavior written in code is rigid. You can execute but cannot manipulate it at runtime. If you need to store, pass, or modify the behavior at runtime, you should refine it, right? So these are the things they are talking about. Then design documentation. So design documentation is the information that completely describes the design process. The term is derived from an idea regarding documenting the design in formal writing. And OOPS allows the reuse of software content. That is why there is a growing demand to document the existing software. It is a good apply object-oriented technology to documentation also. So documentation should be precise in explaining the capabilities of already constructed components. It may be divided into various types like user document, system documentation, and project documentation. So design documentation is part of the system documentation that addresses all interfaces and implementation aspect of software to facilitate maintenance and reuse. One advantage of reusing is improving the programmer's overall productivity and quality of the software. These design documentation include information needed to reuse the software design, information required for implementation and maintenance. So the design document can further be classified as static overview, dynamic overview, class interface description, task interface description, class implementation, task implementation. So static overview is it contains the details of the required platform, its software, hardware requirements, software architecture, specified classes, its organization and description of all classes. Dynamic is it handles all the event information, inter-application communication, control of the flow, etc. Then class interface description, it includes class view describing its various operations and class capabilities. Task interface description, it details the use of classes for new applications or task in document. For example, for a particular task, which class can be used directly or by applying inheritance property, which subroutine or behavior of the class can be overwritten, etc. Class implementation description, it may include the internal structure of the class with detail and the purpose of its data and methods. One important point to note here is that the interface description of class is not discussed here. So task implementation description, it documents the classes or methods that are part of a certain task and is usable for maintenance engineers. So class documentation, description, usability condition, file stores, objective, maintenance, all these things are there. So all the design decision taken by an object designer must be written from an written form and be documented for future reference. It may be the case that the current designer will shift to another place and the new person will come to look after the current project. So in this case, the new designer will use already documented data of an unaccomplished project to get information on the incomplete project. So as in the analysis phase, the system requirement document is prepared in the same way the design document is shown with a more detailed illustration of the object model containing text and graphical representation and a description of all the features like association, inheritance, and abstraction. So a good design document is significant in many areas, like there may be a probability that the software may be divided into many modules and many developers are working on different modules. As there is no technique of software development and that goes in a sequential manner, it is an iterative process, documentation is necessary. Each software is developed in parts or comes in a different version, and it's easy to develop a new version from the previous one if the design is documented. Software is tested and evaluated using many performance criteria, so it must be documented. Finally, maintaining software is very hectic task and requires a document with all its details. Right. The content of the design document may contain a basic architecture of a complete system showing all the classes, its objects, and other required details. Diagrams for different modules can be included for more details. All aspects of the system behavior in different circumstances need to be addressed. So, this is the content. And features of a good design document: highly organized and well structured, summarized, uniform or homogeneous, reliable, and perfectly framed. It should cover all the requirements collected during the analysis phase. It should be less illustrative and more emphasis on images or pictorial representation. This is about how you give a good design document. Right. So this is what they have shown you. Please go through the check progress question of each unit. After each unit, check progress questions are given. So go through them. Right. At the end, the answers for through that questions are also given. So this was about the advanced design, object design, that control and implementation, inheritance adjustment, then association design, object representation, design optimization, design documentation. How do you do that? That is what they are showing in here. This was your block 3. Now block 4, which is your last block, you have implementation strategies. Right, 1. Right. So you have mapping design to code, creating class definition from class diagram, implementing association, unidirectional implementation, bidirectional implementation. How do you do that? So this unit is all talking about how do you map design to code. Now you have made the design, right? Your design document and uh, designing of the software or object oriented design has been complete. Now how to implement that in the code. So in the software development life cycle, when you reach the design part of the software, you can create a design document which includes different UML diagrams such as design class diagram and interaction diagram during the design module. So this document is used as input to the code generation in object oriented programming language. Now it is time to use the design document to start writing code. The mapping design to code means that design classes are converted into program code by writing program statements in a programming language. So classes in the design model can be implemented by writing program code in an object-oriented programming language like C++ or Java or, right? So a design class represents an abstraction of one or more classes in the software implementation. In fact, class and its objects depend only on the implementation language. For example, in an object-oriented language such as C++ and Java, a class can relate to a plain class. The design model can be very near to the implementation model depending on how you draw its classes or classes to classes or similar structures in the implementation language. Right. So mapping design to code is a transformation process from UML class diagram to class and interface definition as well as method definition. Right. So that is what we will do here. So creating class definition from class diagrams. So first, if you see, we have seen the class diagram. I'm just going here. So they are saying a design class diagram helps you to write program code for software application development. Class diagram gives you an overview of your application software depicting classes and the attribute and operation methods and relationship, that is dependency, generalization and association among objects. You are aware of the essential elements of the class, right? So there are many UML oriented tools for transforming class diagram into object oriented code. For example, if you are using NetBeans IDE, then you may add easy UML plugin into NetBeans to solve your purpose of basic implementation. Right. So the following example illustrates how to create class definition from the class diagram. So here they have shown you teacher and student. Two classes are there. Teacher has a method called view student and student has attribute like roll number and name and a method called get detail. Right. So how it is implemented. So if you want to create a student class, you will say class student. This is in C++ we have created. Then string roll number, maybe in java we have created class student, string roll number, string name, right? Public student, and this is a student method we have created, or you can say a constructor we have created of the class. String roll number, string name we have passed here, and we have initialized this dot roll number is equal to roll number, this dot name is equal to name, and we have created this method get detail, public string get detail, and return roll number plus name. We are returning that. And in the teacher class, again, the other class we have created is class teacher, where we are public void view student we have created, and some code will be written here. Example they have given, just right, view student, and it will be calling these parameters also. Now you can add more some more java code to the above example to complete the program. You can compile and run this program to check how this program runs, right? Like here, they have run it, they have taken an example class also. The public static void main, in main is in this example class, and student, they have created object for the student class. S1 is equal to new student, and they are passing the parameters S123 XYZ to the roll number and name. This is a constructor. It will, the object is when you create an object, the constructor is automatically called, and automatically these parameters are passed here, right? So roll number will be S123 and name will be XYZ. And then this is the object for teacher class. Teacher T1 is equal to new teacher. So if you go to the teacher class, so here scanner, scan is equal to new scanner system dot in, system dot println, enter student roll number. So you will enter the student roll number here. String get roll number is equal to scan dot next line, right? If roll number dot equals s dot roll number, so your whatever roll number you have inputted here in the get roll number, that roll number dot equals s dot roll number, that means student s, s is here we are passing, in the view student method we have passed object of the student class. The student class object has been passed here. So s dot roll number, if both are equal, so s dot roll number is the this roll number S123. If whatever we are finding, whatever we have entered is equal to S123, then system dot print get s dot get detail. So get is detail, so it will print roll number plus name. This method is called get detail, method is called s dot roll number. The object of the student class will call this, and it will give the details, something like that. This is what they are talking about. So this is how they have implemented student teacher relationship, right? Now implementing association. Link and association in UML representation are used for establishing relationship between objects and classes. A link is a logical or physical connection between two or more objects. For example, Ram enrolled for IGNOU University. We have already seen how link is done that. So the implementation of association is applied either in unidirectional or bidirectional, as the name implies. So if we have to, like here they are here they are showing an implementation. Manager works for the bank, and manager manages the account, and bank has many accounts, right? So there is an aggregation relationship here. They are showing that. So suppose the implementation of one-way association must be applied in one direction for the reason that a specific link wishes to be traversed in one direction only. So a one-to-one relationship exists between bank and manager, then the simple pointer is used. If there is one-to-many relationship, then multiple pointers are used. So there is a pointer for bank and manager. So as for bidirectional association, they traverse in both directions. Generally, such association do not traverse with equal frequency in both directions. If bidirectional association traverse with more frequency in both directions, attributes should be implemented as a set of pointers. So this approach provides fast access, but you may have to update attributes in both directions to maintain link consistency. It means that if one attribute is updated on one side, then the attribute on the other side must be updated. So here they are keeping pointers. These are the sets. right? So usually the two distinct aspects of implementation of association are under the data declaration is essential to define so that it permits the details of actual links to be stored. It consists of defining data members in one class which can store references to objects of the associated class. If it is required to consider that pointers can be manipulated by the rest of the application, the application's underlying implementation details should be unseen from the client side. This is how they are talking about, right? So first is unidirectional implementation. So unidirectional is one to one association, right? So optional association, in optional association, a link between the participating object may or may not exist. That means a person may have a credit card or may not have a credit card. So this type of association implemented in one direction only, or only in one direction. The figure shows an optional association between two classes, a person and credit card. Every person may or may not have a credit card. If it only depends upon the person's need who desires to take a credit card or not. So they have created like this: public class person, right? Private credit card, C credit card, public credit card get card, right? Return C card. So public void set card, credit card, and an object of the card method is there, right? C card is equal to card, right? Public void remove card, C card is equal to null. Some this kind of a thing. So what this method they are taking is they are getting from the credit card. They have created, suppose they have created a uh, credit card class, and from that they are creating a method credit card get card, and they are getting the card from there. And then here in set card they are saying C card is equal to card, which they are passing as an object of the card, and they can also remove the card by C card is equal to null. Some association they are showing here. Then one to one association is simplest, just like here clock, display time, right? A clock and display is there, so you can public class clock, private display, the display you can show it how it is displaying the time, or a person and account. So a class person, private account, public person, account is equal to new account, public account, get account, and return account. So this kind of a thing they are showing. So each account is associated with exactly one person, and link is traversed from person class to associated account class. So there will be a separate account class for that you have created a object, and that object can be accessed to access the account class. Right, account is created by the person constructor. Person class holds a link to the account class, but not in a reverse direction. So that is what they are showing. Then association with multiplicity many. This type of association exists in those cases where one instance of a class is related to many instances of associated class. You might be seen that every department has many employees. This is an example of one to many association between department and employees. So here, like teacher teaches many students, this kind of a relationship. There is a multiplicity. So a teacher is there. So here they have created a vector. This type of association can be implemented using a suitable container class. The class affirms a vector of students as a private data member, and the methods to add or remove students from this collection by simply calling the corresponding methods defined in the interface of the vector class. They are just giving you examples, right? That is there. Then bidirectional implementation, that means in both direction, one to one can be there, one to many can be there. So the following subsections of associations are there. If it is one to one, an optional association, so one to one bidirectional association, you can traverse from occurrence of one class to an occurrence of associated class, and vice versa, right? You might be able to traverse from an account class to the corresponding person class, and vice versa. So for implementing that here, you have two classes, person and account. Both the classes contain a link through which it is associated. So you have a person class, you have account class, right? And you have a link, like here they have created a link for both. uh, Account class have person class object, and person class have account class object. So each class needs an attribute that contains a reference to an object of the associate class. Each class must have a constructor. The account attribute is initialized in the constructor. So if you see here, this is the constructor of the uh, person class, right, where the account is initialized, and this is the constructor of the account class where the person is initialized, like that. So each class must have a constructor. This account is initialized in the constructor of the person class that is never modified. It is similar manner person attribute is initialized in the constructor of the account class and it is also never modified. Consider the following in Java. So they have given you a Java implementation, how it is implemented. Right. Now, one to many association. Now, one to many association, one source is connected to multiple targets. For example, many students can register for one program. So one to many is there. One person can have many accounts, right? So in object-oriented programming languages, one-to-one relationship are generally implemented with collection objects such as a set, list, or map, or even a single array. Java libraries provide collection classes such as hash set, array list, and heap hash map, which implement the set, list, and map interfaces. So here they are called account is there, right, and person class is there. So where they are using, here they are using hash set. Account is equal to new hash set. So new hash set, if they are using, they have in both, they will have a object of the class, corresponding classes. Account will have person, person will have account, and in the constructor, they in the constructor of the person, accounts is equal to new hash set. That means number of accounts will be there. So they have created a hash set account, they have added here. So that is what will implement the bidirectional association here in Java. Then you have immutable association in object-oriented programming. An immutable object is unchangeable object, and its state cannot be modified after it is created. Whereas mutable objects are changeable objects, can be modified after the creation. Immutable objects are inherently thread safe and offer higher security than mutable objects. Associations and immutable data structures. This means that they carry no state, and a copy of an association is another completely independent association. Consider the example for immutable association. Association between account and debit card are traversed in both directions. It is assumed that there is a restriction for the debit card. It can only be issued to person per account. Only one person with one debit card will be there and immutable. So each class defines a data member with reference to an associated class object. The actual code of the associate included at the time of defining the requirements of the system. So you have a class account and you have another class, suppose debit card, and you have a object of the debit card class also, and a single debit card will be there for each account. That is what they are portraying here. This is the debit card one, right? A single object will be there. That is what is to be implemented in your account. Only one, right? Then they are talking about, just see the check progress questions also, right? Then they are talking about implementation strategies too. So here, creating methods from collaboration diagram. So we know that collaboration diagram is there, which is a dynamic diagram. Collaboration diagram carries a similar type of information as a sequence diagram. It focuses on the object structure instead of chronology of messages passing between them. The sequence and collaboration diagram come under the same head as the interaction diagram. So sequence and collaboration diagram are part of interaction diagram. Collaboration diagram is also called as communication diagram also, and used to represent the object architecture in the system. The key purpose of creating this diagram is to illustrate the relationship between objects and work together to perform a particular task. So for example, you can create collaboration diagram using star URL, so that we know. For first, you can create the scope of the collaboration communication diagram. That is okay. So like here, object A passes a message to object B. This is the first message where then object A passes second message to object C, something like that. If A is greater than B, they are saying if A is greater than B, then object B dot message 1, else object C dot message 2, right? So if A is greater than B, then object B dot message 1 will be sent here to the B. If A is not greater than B, then message 2 is sent, object C dot message 2 is sent to object C. So let's just consider a collaboration diagram for ATM transaction. For example, first you create a use case diagram and then draw a collaboration diagram for the following use case diagram. Customer can insert ATM card into the card reader of the ATM console. The card reader reads and verifies the card. ATM console displays a message and prompts the customer to enter the PIN. Customer enters PIN, ATM console verifies PIN with bank database and confirms the PIN is valid. If PIN is invalid, ATM console notifies the customer with a message and ejects the card. If PIN is valid, ATM console represents a prompt with options such as deposit, withdraw, and transfer money. Customer selects withdraw option. ATM console presents prompts to the customer for an accurate amount to be withdrawn. The customer enters the amount. ATM console verifies the bank with the bank database whether the customer account has sufficient funds. Otherwise, shows an insufficient fund message. ATM console deducts money from customer's account, puts the requested amount in cash dispenser, and prints a receipt. ATM console rejects the card and becomes ready for another transaction. This is what is there. So if you have to make a collaboration diagram for this kind of a thing, so there is a customer, card reader, ATM console, bank database, cash dispenser. These are the things which are there in your this. So customer inserts a card in the card reader. The card reader reads the card with a second message and sends a message to the ATM control, right? ATM console then prompts the user to enter the PIN, prompt the PIN, right? Then the customer enters the PIN. Fourth message is customer enters the PIN to the at the ATM console, right? Then PIN is verified from the bank database. Verify PIN. Fifth message is there. Then if the message is incorrect, then it will eject. If your PIN is incorrect, then it will eject the card at the ATM console. If it is correct, then 7 messages prompt the options to the customer, right? The customer selects the option like withdraw money. He selects the option, right? 8 messages, he selects the option. At the ATM console then prompts the amount to be withdrawn to the customer. The customer enters the amount, right, to the ATM console, and then ATM verifies the amount from the bank database, that the amount is available or not. Then the bank deducts the amount from the database, right, and puts the cash in the cash dispenser at the ATM, and then it prints a receipt. This kind of thing is a communication or collaboration diagram, right? So when you create a collaboration diagram for the real business application, you can create methods as per your need. The classes and their methods are created in the collaboration diagram. So you have customer, insert card method, enter amount, select option, enter PIN. And class, then ATM console is another class, and it has methods like prompt PIN, verify PIN, prompt option, prompt amount, verify amount. And card reader class has read card method. Bank database has eject card method, deduct amount, put cash, and print receipt. So now you can transform methods defined in the collaboration diagram into executable code. Now you can design the code for insert card, enter amounts. So you inscribe source code yourself or use software tools such as Ellipse and concurrent version systems. There are a number of methods in the figure. But the pseudocode given below is written for verify PIN method only. This method verifies the customer's personal identification number. So what they have given here is they are verifying a simple method. They have given you a kind of a pseudocode, you can say. So method verify PIN is there. So they have defined constant number of max PIN is 2. Maximum pin you can enter is 2, so maximum you have entered the constant to 2. Verify pin count is a number, so variable you are declaring pin and pin count, right? Set pin count to 0. Read pin from ATM card, so you will be reading, and that means input the pin number. Loop until pin count is equal to number of max pins. So you will also see that the pin count is equal to number of max pin. Until that you have to read the pin, otherwise you will not. Let the user enter the pin after 2 attempts. You can put 3 also, it's just an example, right? It is 2 here they have put. So input pin from customers. So if entered pin matches with the card pin database, then call prompt option method. And if, right, then add 1 to pin count, and then otherwise it will add 1 to the pin count. That is what they are talking about, and the loop will end, right? If pin count is equal to number of max pin, then seize customer card, else call eject card method, and if end method, and verify pin. This is how they have implemented it in program. So consider that another example of program management system. Using this example, you can learn about creation of method from collaboration diagram. System contain classes like admin, program coordinator, program host, and faculty. Admin initiate the manage program functionality and interacts with program coordinator. The program coordinator intermingle with different object classes in the system, such as program, course, and faculty. The program coordinator starts the process of creation of and modification functionality of the program. After the program is either created or modified, program coordinator is responsible for creation of modification functionality of a course. Each program consists of many courses. It means that the class program and class course are associated with each other in the form of one-to-one relationship, one-to-many relationship. The program coordinator assigns to course to faculty. Finally, the admin invokes the assigned faculty to course functionality of the program. So this is what. So admin manages the program. The right program coordinator creates a program in the program section. Right, he can modify a program also. Right, and he can remove a program also, and he can view a program also. Right, then program coordinator can create a course also, modify the course, remove the course, view the course also. Program coordinator can assign course faculty, modify course faculty, remove or view the course faculty. And program and course have a relationship one to many. This kind of a thing they have created. So they are saying you have admin. So you have a process called manage program, and you have a program coordinator. So program coordinator can create program, modify program, remove program, view program. Right, faculty can be assigned course faculty, modify course faculty, remove course faculty, view course faculty. Course has create course, modify course, remove course, view course. This kind of a thing. This is all this from this also different implementation of manage program, create program implementation can be made. Example they are telling. Then implementing constraints. So in any product is well designed if it will yield fruitful results. In the same similar manner, if you want to design a software application with the sound quality of information, and it should be designed with appropriate constraints in the analysis and design phase. If your application is not well designed, it will be erroneous and more expensive to correct. In general terms, constraint means restrictions or limitation that is used for optimization purposes. So we are talking about constraint. So constraint is a condition that restrains the semantics of an element, that it must always be true. For example, a person can only get a loan from a bank if the person has an account with the bank. A constraint is either to be declared in the tool and used in several diagrams, or identified and applied as needed in a diagram. Some constraints are predefined in UML diagram and others may be user defined. So when you build a business application, they are closely associated with the constraints. So using the constraints, you can control the software behavior. Right. So constraints are used as semantic checks that are implicitly satisfied a given set of objects. For example, constraints can control the range of an object's integer attribute. You can say that the constraints are defined as rules to be applied to classes and or field attributes of the class. For example, if a rule dictates that the employee name may never be null, then you would like to place an at the rate null, not null annotation to define the constraint like the following. Right? You want the employee name should be not null. The constraints are used to represent the semantics of object-oriented model elements such as objects, links, and attributes. So they are talking about that, right? And constraints is they you can use a constraint on a single element such as class or an associated association path. Text for constraints may be positioned near the name of the class element and placed on a note like this. We have seen it in the diagram also. You can give a constraint, right? So constraint on objects like here, the constraint is that the salary less than equal to boss salary, right? So here they are saying it is defined as condition within the braces placed near the constraint object and then connected with dotted line like this, right? So worker salary cannot exceed the salary of the boss. So salary should be less than equal to boss salary. This is the constraint, right? Constraints on links also can be there, right? Like here, the multiplicity specifies how many objects of a class can be coupled with an object with the other association class. So multiplicity constraint restricts the number of objects associated with given object. So object modeling notation define the syntax for displaying multiplicity values like 0 1, that is 1 to 0 or many, or 0 or 1 or 1 to 1 1 to many, same thing. It has a special notation ordered which defines designates the elements of many side of an association have an explicit order that must be maintained. The following object model as shown in illustrates regional centers of university. Each regional center for each university has a set of employees who have held the regional center ordered chronology like this. The university have regional center have employees, right? So constraints are commonly used for various elements of a class diagram, right? They work as a bridge to develop functional relationship between the entities. So like here, you have job and candidate. So if the age of the candidate is less than equal to 30, then he can apply for the job. Otherwise, he cannot apply for the job. The candidate do not apply for the job if the age of the candidate is more than 30. So that kind of a thing. So that is what constraint is. Now here, like in saving bank, you have withdrawal amount is greater than equal to balance amount, right? So let us consider the class diagram for implementing, right here. So here, balance amount is equal to balance amount minus withdrawal amount. So if withdrawal amount is greater than equal to balance amount, I think they have given it wrongly. If it is greater than withdrawal amount is greater than equal to the balance amount, then it cannot be deducted. This is wrong. This should be less than. If your withdrawal amount is less than equal to the balance amount in your account, then balance amount will be equal to balance amount minus withdrawal amount. It is less than, not greater than. So this thing they have the operator they have used wrongly. So how they have made it, you have a class saving bank account and there is a withdraw method, public void withdraw, and double withdrawal amount is the variable they are passing, parameter they are passing to the withdraw method. And private balance amount they have created in this method, a variable. Now they are checking if the withdrawal amount, whatever you have entered to withdraw from the bank, is less than equal to the balance amount, then balance amount will be equal to balance amount minus withdrawal amount. Otherwise, else it will show an error. This is how you have to make it. It should not be greater, it should be less. So there are a number of constraints such as not null, unique, primary key, foreign key in RDBMS, which we will study in the next section. So that is what that those can also be applied through DBMS also. That is their database management system also you can apply. Then they are implementing the state charts also. the state chart diagram which we have seen. Like here they are showing that start your initial stage, you enter the login details and the authentication is done. If it is invalid, it again goes back. Invalid login is there, then again it comes back to the authentication stage. Otherwise it enter the ticket details. So you you log into the system, see the availability of the seat, check the availability of the seat, then you enter the passenger details in the booking ticket, and then you make the payment. If the payment is successful, then ticket is printed. If the payment is not successful, again it comes back to the payment module. So if it is successful, ticket is printed and you log out of the system. A simple booking ticket implementation is shown of this, right? So here, how do you implement state chart using switch statement? So switch statement, you can use switch statement also, like here. So if you are login, then you go to the authentication stage, other and then you go to the seat availability, say something like that, right? So how they have implemented, we are just seeing that. Here they are saying you have a stop button. Initially stop, right? And when you start, you press the start button or play start, it starts to play, right? And when you press the stop button or play stop, it goes back to the stop state, something like that. So what they have shown here, this uh, consider the following state chart diagram as shown in figure 13.10 for the video player application with two states, stop and play. In the stop state, when a user presses a play button, then play button event happens and the device executes the play start action and goes to play state. In the play state, when the user presses a stop button, the stop button event generates and the device executes the play stop action and goes to the stop state. While implementing the state chart, there are four classes: video player, player state, stop and play. The video player is super context class and player state is an abstract state class. The two classes such as stop and play, which implement the behavior specific to stop and play states respectively, and they are subclasses of player state class which offers a common interface for all state classes. So these classes are called state classes since they implement individual states of the state chart involved in the domain. So they are saying that player state is a abstract class, that is your base class, and it will have two classes, stop and play, right? And you also have a video player class, which is a super context class. So this is a video player class, and it is calling the player state class here, right? And there is a method for play and stop button here, right? And this is a player state class, and it is calling the video player object. It is making the video player object, and it is also calling the stop and play buttons here of the base class, right? And class stop extends player, that means stop is part of the player class, and how it is stopping, it is the super class is the video player. So how it is stopping, it is made here. And play also extends the player state, again the super class is your video player class, and how it is stopping, it is made here, something like that they have made. So this is what they are talking about. So that is what is there. Then they are talking about persistency, that is database. Persistency means preservation, means storing. You have to store the data. So data persistence means this can be asked. This question can also be asked to you. What is persistency? So in files or databases, the object life is longer than the duration of the process creating and using the object in a program. This property by which an object stays even after its initiator concludes, close the program, is known as persistence. So persistence is important for enterprise application because it gives required access to relational database. So data persistence, you all know computer programs operate on data. The most important tasks like application performs are to save and restore data. Persistent data may give useful mechanism for passing data between programs and permits a program to resume processing after a while. So that is why you are saying that you have to store the data. So process persistence represents a lifetime of a process or an object, referring to the computer thread and process. A persistent process is a process which cannot be killed or shut down by the process until the user kills them. Right. So object persistence is there in connection with data. Persistent means an object should not be removed except it is actually erased. This requires appropriate storage and certain procedures which permit the data to persist. So persistent data is steady and restorable and is accessible after closing the application. That is persistent data. This type of data must be saved into a database or internal or external memory, whereas non-persistent data is not accessible after closing the application. Non-persistent data is volatile data that is available during the application execution, and after the application is closed, it is lost. Right? So, for example, relational database management systems store persistent data in the form of records and tables and are accessible even after closing the application. So you should know what are transient data and what are persistent data. You should identify them. Transient will be temporary until the application is running or the program is running. You need that data. After that, it will automatically delete it. But persistent data is the one which will remain even after the application closes and it is stored in the database. That is what is there. Then what is serialization? Serialization is the process of transforming an object into byte streams to store the object to memory or a database. That means you have to store the object into a database. So in the form of bytes, you have to store, that is serialization. So you have to transform that object into byte streams. So serialization main objective is to save an object state so that it recreates when needed. So suppose in halfway you have stored the data and still the data complete data needs to be stored. So up to where the state is there, right, that it needs to be stored. So that happens with serialization. The inverse process is known as deserialization, and this process is used to convert the byte stream to actual Java objects in memory. Right. So that is what serialization and deserialization are. Then we come to the next unit, which is object mapping with databases. So we are doing object mapping with databases. So you know about you should know about relational database schema. You should know about database DBMS. That is a software program which is used for creating, retrieving, and controlling access to permanent data, and it also helps you in integrity, security, crash recovery, data distribution, sharing between users as well as applications. So there are some key terms: data schema, database schema, data constraints, data dictionary, database design. So these are some of the things. So database schema is the design of a database. It is a frame of the database that signifies the structure, the table, and the fields and column and all that, right? And database data constraints are the constraints which you apply on the data, like primary key, unique key, default, check constraints, whatever can be there, right? And data dictionary is a database schema along with numerous constraints on data is stored in a database catalog or dictionary. It is known as metadata, data about data, right? Metadata is data about data. So database design is an important task for any business database application. Database design describes the database structure used for creating and storing information. So there are two methods to design a database: attribute driven design and event driven design. So in attribute driven design, assemble a list of attributes related to application and normalize the sets of attributes that preserve functional dependencies. In contrast, the entity design, driven design method define entities which are significant to the application and explain them. Usually database design is limited entities as compared to attributes. Right. So three schema architecture is there. You have an external schema, conceptual, and internal. External schema is external view which represents the some portion of the entire database. It is higher order abstraction which is seen by the user. The next level is conceptual view which represents data logically. It defines what data is stored really in the database. The third level of the architecture is an internal schema, which shows the lowest level of abstraction and closest to physical storage. Object modeling is suitable for designing both external and conceptual schema. Right. So we are talking about the conceptual schema, right? So here we are talking about, right, RDBMS, logical data structures. First, we'll talk about that. So in RDBMS, what is a relation? A relation is a two-dimensional table. That means row, a collection of row and column is a table. Row is also known as tuple or a record. Column is known as attribute, right? So a row is a horizontal portion of the table. One row denotes one record of the table. Each row is in a table is identified by a primary key that does not permit duplicate row. Column of a table are called as field names or attributes. Column is the vertical portion of the table. The number of attribute column in a table is known as degree of the relation. The number of rows in a table is known as the cardinality of the relation, right? So that is there. Now relational DBMS concept, RDBMS operators and commands are there. So you have different query languages. Data definition language, SQL has many processing capabilities. Data definition language, data manipulation language, right? So data definition language where you define the database. So you create table, alter, create, alter, and all those commands come in data definition. And data manipulation language, you have the command like select, insert, update, and all that will be data manipulation language, right? Then for the SQL query, then RDBMS integrity rules are there. So there are two rules. These are two integrity rules by CORD. CORD rules are, these are also called CORD rules. So integrity rule one is entity integrity. It defines that each table have exactly one primary key. A primary key is a set of one or more attributes that can uniquely identify each row in a column. So if you want to identify each row, uniquely identify each row in a column, you need to create primary key. That is entity integrity. Referential integrity is the second integrity rule. It needs that a foreign key must have matching primary key. Referential integrity constraint ensures that relationship between records in related tables are valid. Right. So suppose if you see here, a foreign key is a primary key of one table that is embedded in another table. So the primary key as well as foreign keys are shown here. So if you see course table is there, student table is there. Course has course code and course name. Student has roll number, name, age, and course code. So if you see here in course table, course code is the primary key. This is the primary key. And in student table, roll number is the primary key of student table. And student table also have one more thing, course code. So what is course code in student table? It is the foreign key to connect both of these. If I want to know that what is the name of the course Ram has applied, the course code of Ram is MCS 218. So what is the name of that course? Is data communication component. If you want to know, you want to connect these two tables by this foreign key. So this course primary key of one table is connected to the foreign key in another table to know the thing. So then the above example shows primary and foreign key. In this example, there are two tables, student and course. Course code is the primary key of the course table and roll number is the primary key of the student table. Course code is a foreign key in the student table. It would not be acceptable to change Mohan course code for MCS 221 because MCS is not defined in the course table, right? Then they are talking about normal forms. You have normalization. Normalization helps you to reduce the duplicacy in the data in the database, right? Unnecessary repetition will be reduced, and data will be defined in a structure, logical structure. So you have 1NF to 5NF and BCNF. So first normal form is there. So table is in first normal form if and only if all underlying domains of the table contain atomic values. Yani that means no repetition of values is there, single values are there, unique. A table is in the second normal form and it satisfies the first normal form. Every non-key attribute fully dependent on the primary key. So you create a primary key and all the non-key attribute are dependent on the primary key, and a table is in the third normal form if it is in the it satisfies second normal form, and every non-key attribute is non-transitive dependent on primary key. So this kind of a thing is there. Then you also have a view, which is a virtual table whose content are derived from one or more tables depending upon the condition. A view does not physically store data in the database. It is you just like any other table. A view is like a query like select from clause that works on physical data. Right. So sometimes you require a view where you want that two or more tables data needs to be collected. So that's why. Then object classes to database table. So we are talking about that. So they are talking about. I'm not going through this. They are explaining the this. So now you have vertical partition. This is known as vertical partitioning, right? Student ID name, student ID address. This is horizontal partition, student ID, name, address, student ID, name, address. So this is, you have divided this data. This is horizontal partition and this is known as vertical partition. Right. So here they are saying when you map class objects to relational model, you shall start with attribute of a class. These attributes will translate to one or more columns in a table of relational database because some of the attributes are used for temporary calculation. For example, an employee class may have a gross pay uh, attribute that is used for some calculation. So basically, I'm just telling you how that this is your table and how it is made into a SQL code. So if you see here, you have create table student. So the name of the table is student. Student ID is there, and not null it will be. Null is no, so not null. And name, and it is ID. Domain is ID. That means primary key is student ID is given here, and name is variable is varchar 30 and not null, and address is varchar 30 but null is allowed, so we will not give not null here, and primary key like that they are allowing it. Then if you have to say one-to-one association country and city, so country code is the city code, and get country code and has a capital city like this. So if you have to implement that, you will create table country, country code, country name, and primary key is country code, and create table city. City code is the primary key, city name, country code will also be there. The country code in this table city code has country code is the foreign key to the this city. This is how they have created as capital. Then university employee and university employee. This is a ternary relationship, university and employee, right? So you have university table, employee table, and university employee. So you have to create three tables. So the third table, this university table will have primary key as university ID, employee table will have primary key as employee ID, and the third table, university employee, will have university ID, employee ID as the primary key also, university ID, employee ID, and foreign key also. These both. This is ternary relationship. And then you have many to many association also. So you have table post, table student, post as postcode as primary key, student as student ID as the primary key, and then primary key in the registered for, you have postcode, student ID as a primary key, and postcode and student ID as foreign key also. So something like that. So you can see that I'm just giving you an example. Again, they have taken the course, student, and assignment all have primary keys, and the third ternary table will have postcode, student ID, assignment ID as the primary key, and postcode, student ID, assignment ID as foreign key. This is how they have mapped it, right? So you can see that it's not a problem. This is all what your syllabus was all about. Implementing strategies. One. So tell me any doubts are there, class, whatever you have studied. You can submit the assignment at the study center in hard copy, but it is beneficial if you submit it in the link given on the Merit website. You can scan your assignment. The theory assignment should be handwritten. Practical assignment can be a soft copy, right? So you can submit it on the link also. See which is your study center and you can submit that, right? So anybody has any doubt? This is your last theory class for this session, and no, hard, the hard copy, both hard or soft copy should not be submitted. Only one should be submitted. Either you submit the hard copy at the study center or the soft copy, but it is better you submit the soft copy. Both are not allowed. Only one thing is allowed. So if you want to submit it, I am just opening the Merit's website. If some of you doesn't know where, if your study center is Merit, the online mode student, MCA OL student, will not submit the assignment to the study center or regional center. They will submit the assignment on their LMS portal. Remember that. जिसको नहीं पता है, जो ऑनलाइन मोड के स्टूडेंट्स हैं उनके लिए एलएमएस पोर्टल है जहां पे उनको अपना असाइनमेंट सबमिट करना है. जो ओडीएल मोड के स्टूडेंट हैं उनका स्टडी सेंटर अगर मेरिट है, ओडीएल मोड की बात कर रही हूँ, ऑफलाइन मोड, तो वो मेरिट के वेबसाइट, ये मेरिट की वेबसाइट है merit.ac.in, राइट. यहाँ पर आपको असाइनमेंट सबमिशन लिंक दिया हुआ है. वो स्टूडेंट जो ओडीएल मोड के है, ऑनलाइन मोड नहीं सबमिट करेगा यहाँ पे. वो यहाँ पे ऑनलाइन, थ्रू ऑनलाइन मोड यहाँ एक एक सब्जेक्ट एक एक बार सबमिट करेंगे. ठीक है. थ्योरी असाइनमेंट शुड बी हैंड रिटन, right? And practical assignment can be a soft copy, but that means on a word file you can copy the code and diagram or screenshot, whatever you want to give, you can make it on the word file. But theory assignment should be handwritten. That is what the thing is. Just write it again, no problem. Your name and enrollment number for the attendance, right? Then we'll end the class, and now we will meet in May. I don't know what date it is. For the practical sessions, we will meet it in May. We will meet. Anybody left for the attendance? Should we end the class, please? How many people are left again? So I'm ending the class now, right? You may be having some other class, and you can join that. I don't know. It may be available all for MCA OL student or for others. I don't know. You can ask the study center where your this online recording is there, but where it will be available, you can ask them. I think on the RC Delhi one website or something, they will be you will be accessing. So just ask them where it will be available. Okay, then take care. I'm ending the class, and we'll meet in May for the practical sessions then. Welcome. Bye.